So as you already heard, the main reason Code RealTime exists is that we want to bring the same functionality as we have in Model RealTime, but for users of other IDEs. And we are currently focusing on Visual Studio Code and Eclipse Thea. Maybe we will add more IDEs in the future. We are implementing this using the language server protocol, which means that most parts of what you saw in the demo is actually independent of the IDE itself. So there is a language server running in the background which implements all the tricky parts, and then we have just a thin UI layer that runs in Visual Studio Code and Eclipse Thea. Both these code and Thea can run either on the desktop, as I showed in the demo, but it can also run in a web browser. In particular, Thea is easy to deploy in a web browser. And we have these three notations that we keep synchronized, and they are at different abstraction levels. So we have the graphical diagrams at the highest level. We currently support state structure diagrams, as you saw in the demo, but also class diagrams. So I didn't show that, but they are identical to the UML class diagrams you have in Model RealTime. And those graphical diagrams are great if you need a high abstraction with few details, just to look at something and understand it, maybe do some editing. But in the middle of this hierarchy, we have the textual language, which is also the storage format. So the art files, that's where we store everything. Those are the files you will put in Git. And after a while, you will probably prefer to do most editing on that level. And then we have the generated code, which gets generated from the art files, which is very similar to what the code that you get from Model RealTime. There are some improvements and some differences, but to the most extent, it's very similar. And when we designed art, we wanted to really separate that level from the C++ code. So we didn't want to have any duplication at all. So that if you know C++, then you know most things actually in this tool. And then you only need to learn those few concepts that art provide, that for which C++ doesn't have any similar concept, like state machine or protocol or event. And to summarize, we use C++ for actions and expressions, but also for types. And sometimes you can annotate those types with the C++ attributes, and then the code generator can know that it should generate some additional boilerplate code around the type. So for example, type descriptors is done not by specifying properties like we do in Model RealTime, but simply putting a tag on a type. And then the code generator knows that this type is something that the user wants to send, for example, between two capsules. Then it has to generate a type descriptor for that type with the usual copy, move, init, destroy, encode, decode functions. The value that Code RealTime provides is I think, to most extent the same as Model RealTime, but in a slightly different way. It's about abstraction, automation, analysis. And for abstraction, we have these high-level concepts that you don't find in a language like C++, capsules, state machines, etc. And also the ability to put the code inside these art files, as you see with the blue rectangle in the picture. The graphical diagrams is, of course, also an example of abstraction, which makes it very easy to understand, for example, how a state machine works by just looking at it graphically. For automation, we have the automatic code generation that runs always in the background, so there is no need to perform any step to get the code. It's always happening. And we support build variants in the same way as we do for Model RealTime, so that you can build multiple variants out of an application and define high-level build settings. I didn't show you so much about analysis in the demo, but that's also an important part of it. So we do run a large number of validation rules as when you edit your art files. So you see one example here in the picture that the tool has detected that a capsule has a transition that is unreachable due to how the guard conditions have been written on transitions or triggers. So this is an example of a transition that cannot run at runtime because it cannot happen, it cannot be triggered, and then we detect that immediately as you type. And there are around almost 50 such checks that we do. We also detect build setting inconsistencies by analyzing the TCs, and this is a little bit extended compared to what we do in model real-time. So for example, here you see in the screenshot that we have analyzed the thread properties, so that if you have a library that defines a logical thread, but then you forget to map that logical thread to a physical thread in the executable, then that is detected. And this is something that otherwise would lead to some runtime surprise that something didn't run as you would expect it to run. So there are community edition and commercial edition, like I mentioned. These screenshots they are a bit old now, because I think tomorrow the new version will be available with the new name, Code RealTime. And you can choose if you want to go to the Visual Studio Marketplace or the OpenVSX Marketplace, depending on if you use Visual Studio Code or Eclipse to download it. And with the commercial edition that you all are entitled to, you can use this for commercial purposes. You will have the source code for the target RTS, and you are entitled to support, just like for model real-time. Yeah, we already did the demo. So any questions or comments from anyone?